Good morning students. Today we are going to discuss about Newton's second law of motion. Before that, before understanding Newton's second law of motion, let us understand one important physical quantity, that is momentum. We can develop the concept of momentum through some examples. For that, a tennis ball hits a player does not hurt him, but a fast moving cricket ball hits a spectator may hurt him. A truck at rest does not hurt anybody, even parked along a roadside, but a moving truck, even its speed is less, may kill a person standing in front of its path. Similarly, a small bullet that fired from a gun may kill a person standing in front of it. From all these observations, we can conclude that impact produced by a moving object depends on its mass and velocity. So, the product of mass and velocity is called the momentum of a body. Momentum is a physical quantity which gives the combined effect of mass and velocity. The letter P is used to represent momentum. So, momentum is equal to mass into velocity. That is P is equal to M into V. The SI unit of momentum is kilogram meter per second. Momentum is a vector quantity. Its direction in the direction of the velocity. Its velocity is in the direction of velocity. Next, about Newton's second law of motion. Newton's second law of motion states that rate of change of momentum of an object is directly proportional to an applied unbalanced force, and the direction changes take place in the direction of applied force. Consider a force F. Consider a force F acts on an object of mass m. Then that object changes velocity from u to v, where u is the initial velocity of that object and v be the final velocity of an object. So what about the momentum? The initial momentum of the object P1 is equal to m into u, and P2 is equal to m into v, that is the final momentum of the object. Therefore, change of momentum is equal to P2 minus P1, which is equal to, what is P2? P2 is mv and P1 is mu. Substitute in this equation, we will get change of momentum is equal to mv minus mu, which is equal to, here m is a common factor, so we can take outsider. So, m into v minus u. This change of momentum take place in time t. Then, therefore, rate of change of momentum is equal to m into v minus u divided by t. We know that from the equation of acceleration, we know that a is equal to v minus u by t. So, therefore, rate of change of momentum is equal to ma. That is m mass into acceleration. That is mass into acceleration. Then, according to Newton's second law of motion, force is directly proportional to the rate of change of momentum. Clear? So, F is equal to K into M. Not to replace this proportionality constant, we can take a constant K. So, F is equal to K into Ma, where K is a constant, its value is equal to 1. Okay. So, the second law of motion states that the rate of change of momentum is directly proportional to the applied unbalanced force. That is, F is directly proportional to ma, or F is equal to Kma, where K is a proportionality constant and its value is equal to 1. Next, about the unit of force. We all know that the unit of force is Newton. So, now to define the Newton, we can take mass is equal to 1 kilogram and acceleration is equal to meter per second square. So, F is equal to 1 Newton. How can we define 1 Newton? 1 Newton is that force. 1 Newton is that force which produces an acceleration of 1 meter per second square in the body of mass 1 kilogram. This is about Newton's second law of motion.